Jamb 2026 candidates, by the grace of God, this is the final topic in our high yield calculation for physics. So we've rounded off physics completely. We don't have any other calculation that we are solving again because we have completed the high yields like I promised. Okay, the one we be say that they always be set. Okay, like I told you, I'm not going to treat all the calculations. Okay, treating all the calculations might cause you more harm than good. Okay, so you just have to know the ones that are commonly set and master them, and when you see them in the examination hall, you just solve them easily, get your mark, and you come up for there. You are not there to score 400 over 400. You are just there to score something significant to land you admission to your dream course. All right. So if you need assistance, shortcut for last minute preparation for this Jamb UTME, do not hesitate to send me a DM. May you not take this exam 2027 again. Because if you want to take them for 2030, I did for you. I will still prepare you. So me once make you do this thing once and for all. Pass. Okay. So you have to take a bold step now. Send me a DM to get all the small short materials where you need. Maybe they blast this exam. Now my WhatsApp number be this one. So all right. So the question we have here is under electrostatic force. That's the topic. We are going to do 2 questions under this electrostatic force. And the first question here, Jamb must repeat question 1. The question reads, calculate the force of attraction between 2 points, plus 4 U coulomb and minus 6 U coulomb, placed 50 centimeters apart in vacuum. This K, which is constant, or coulomb constant to be more specific, is equal to 9 times 10 raised to the power 9 Newton meter square coulomb square. All right. All options represented in what? Newton. That's they told us to calculate force of attraction. Force equal to question mark. Now we define. Okay. So we have to solve very fast. Very fast. No time. First of all, since this one they talk about 2-point charge, we already know our Coulomb's law we go use. What is Coulomb law? You know Coulomb's law now. Coulomb's law. Okay. Coulomb's law. Okay. The expression of Coulomb's law is given as. The expression is giving us F, which is the force between 2-point charge, is directly proportional. This one is what the Coulomb's constant. All right. The distance between the charges, charge 1 and charge 2, and inversely proportional to the to the square root. Okay, the square root of their distance apart. So Coulomb's law states that the force of attraction between 2-point charges is directly proportional to the sum of the charges. Sorry, not the distance of the charges. The sum of the charges, and inversely proportional to the square root of their distance apart. So in other words, force of attraction is equal to the sum of charges. Okay, and inversely proportional to this one now. This force now, this same force is inversely proportional to the square of their distance apart. All right. So this one now be the formula. Okay, the expression from the Coulomb's law. That's what we are going to apply here. And do not forget that you can be given, a question where you have to include the what's it called? There's a constant you have to include, which is 1/4 pi E naught, epsilon naught. Okay, permittivity of free space. All right, we have to, if permittivity of free space is involved, you have to include this into the formula. So you are now going to get something like F is equal to 1/4 pi E naught. K, you will now add it to the Coulomb's law formula 1 Q2 over R square. You are now going to use everything to solve together. That's if you were given this epsilon naught. That's what's it called? Permittivity of free space. But it wasn't given in this question, so we don't need this one. We don't need this permittivity of free space. Okay. So in this formula, I don't think there's going to be time for that one. But let me just write it. Okay. F is equal to what? The electrostatic force. Okay. Force. Usually in Newton. Okay. Why Q? The first Q. Okay, the first one are constants. K equal to what? Coulomb's constant. Coulomb's constant. Okay, constant. And the constants they give us for here, so it's usually 9 times 10 raised to power 9 Newton meter square coulomb square. Now they usually be. Q1 and Q2 are the point charges. Okay, these are the charges or the point charges, and they are usually coulomb. Okay, coulomb. Usually in coulomb. What we get again? We get R square. And this R square, now they are their distance apart. R is usually the square root of their distance apart. Okay, but R, we are using R here. Okay, equal to the distance. Okay, distance. Okay, distance apart. That's distance between the charges in meters. Okay, it should be in meters. Okay, so if we write out all we were given here, or maybe we move over to the second side, or let me just bring something. Let me bring another paper to do this rough work here. So first of all, let's write out all we were given to solve. Given, okay, what did they give us? They gave us the force of attraction between 2 point charges. The first one is, okay, Q1 equal to plus 4 new coulomb. Okay, Q2 equal to minus 6 new coulomb. All right, and they gave us 50 centimeter away. This one are the weighting R, which is what? The distance equal to 50 centimeters away. They give us what again? Sorry, 50 centimeters apart. They now give us this constant, 9 times 10 raised to power 9 Newton meter square coulomb square. All right, so if you look at this is a new coulomb, and all these are supposed to be in coulomb. If you look at what we have here, see, they are supposed to be in coulomb. The charges, look at it, the charges should be in coulomb. Okay, okay, so we have to convert. Okay, so since 1 in coulomb is equal to 10 raised to power 9, because they can give you as 1 in coulomb instead of new coulomb. Okay, instead of new coulomb, they can give you 1 in coulomb. Okay, depending on what they give you. You all know that 1 in coulomb is equivalent to 10 raised to power 9. Okay, and also since new coulomb, okay, 1 new coulomb is equal to 10 raised to power 6. That's 1 million. So this will now enable us to what? To convert all these stuffs we have here. Okay, it will help us to convert all the stuff we have here. So the first one we are having here, we are going to convert it to, the first one we convert it using this 1 coulomb is equal to 10 raised to power 6. See something, it's like this, it's 10 raised to power 6. So one new coulomb is equivalent to 10 raised to power 6 coulomb, or 1 million. Okay, but since we are converting from new coulomb to coulomb, and coulomb is bigger, we are now going to do what? We are now going to divide whatever we have here by this. Okay, if we divide whatever we have here by this, we are now going to get raised to power minus. Okay, we are now going to get raised to power minus. If you divide 4 plus 4 divided by 1 million, you are going to get equal to, or let me just put it here, plus 4 over 1 million. 1 million. Okay, equal to 0.000004. Okay, so if you convert this to standard form, you are now going to have 4 times 10 raised to power minus 6. Okay, if you do this one, the same thing here. If you do the same thing here for this one, you are still going to get the same 6 times 10 raised to power equal to 6 times 10 raised to power minus 6. All right, so these are our new charge 1 and charge 2. All right, so we have to look at if we are to convert any other thing. Look at this one again. Distance is supposed to be in meter. Okay, centimeter is not the standard unit for distance. Even though you look this place, you see and say, we say distance apart should be in meter. So we have to convert it to what? Meter. So to convert this to meter, we will now do 50 divided by 100. That should give us how many meter? That should give us about 0.5 meter. Okay, so we are done with the conversion. We don't have to convert anything again. So we can now apply the Coulomb formula, F equal to KQ₁ Q₂ over R square. All right, F now is equal to what? What is our K? Our K is 9 times 10 raised to power 9. Look at it here. Our K times weighting. The first charge, Q1, which is now this, 4 times 10 raised to power minus 6 times Q2. What is our Q2? Our Q2 is 6 times 10 raised to power minus 6. Okay, over R square. R is 0.5. That's 0.5 bracket square. Okay, so this is what we have. So because this thing too big, make we first do the numerator first. Make we simplify the numerator first. Okay, so simplifying this numerator, we will just carry all this raising power go one side, solve on one side. Okay, first of all, make we just solve the raising power. Bracket open. 9, see the first one, 9 minus 6. Okay, minus 6. Okay, 9 minus 6 minus 6. Okay, 9 minus 6 will give us 3. Minus 3 minus 6. That's why it's always good to just convert. Since you have calculator inside Jamb, just convert all these things to decimal. Convert all these things to decimal, because sometimes they can be confusing. Let's just do 9 minus 6. 9 minus 6 will give us 3. Okay, 3. 3 minus 6 will give us minus 3. Okay, so our power now is equal to minus 3. The raising power is equal to minus 3. So if we simplify this, 9 times 4 times 6 will give us what? 9 times 4 times 6 will give us F now is equal to 216. Then we put this our power, raising power minus 3, bracket close, over what do we have below? 0.5 times 0.5, we get 0.25. F now is equal to this. Let's just turn this, because actually what we have here is 2.16 times 10 raised to power minus 3. Something like this. 0 times, sorry, 216. Okay, that's what we have here, over 0.25. Okay, let's use calculator to finish up this thing. F is equal to 0.864. That's the answer. So this 0.864 is the final answer. 0.864 Newton. So among the options, let's see if we have any match. Okay, C, option C is the perfect match, is the closest answer. Option C. Let's move on to the next question.